Hi again. This is Tim Shu from San Jose State University, and I'm here to talk about inverse functions. I'll start by talking about what a one-to-one function is. We'll talk a little bit about the definition of the inverse of a one-to-one function. We will compare the global attributes of a function f and its inverse f inverse. And finally, even though, as you'll see, this is not strictly necessary for calculus, we'll talk about finding the formula of an inverse function. Okay, so first we have to talk about one-to-one functions and what they are. So a one-to-one function, y equals f of x, is a function that never takes the same y value twice. It never has the same output twice. So equivalently, another way of describing one-to-one functions is that a function y equals f of x is one-to-one exactly when, if and only if, any horizontal line that passes through the graph of y equals f of x, it passes through it at most once. You may know that as the horizontal line test. All right, so turning to some examples of functions, here's an example, the sine function, graphed here from negative pi to positive pi. So the sine function is not one-to-one because it takes the value of 1/2 at least twice over here and over here. You can see that it fails the horizontal line test because this red horizontal line here at height 1/2 passes through the graph twice, fail. So the sine function is not one-to-one. On the other hand, it can be shown that the function f of x equals 2 to the x is one-to-one because it never attains the same y value twice. So whatever kind of horizontal line you have here, it'll only ever pass through the graph once. Now that's not obvious from what we talked about so far, but it is true. For the future, we'll note that, let me recall, that the domain of 2 to the x is all real values of x, and the range of 2 to the x is all y greater than 0. Okay, so now we turn to the definition of the inverse of a one-to-one function, one example which we just saw. So suppose y equals f of x is a one-to-one function, then the inverse function f inverse of x is defined by saying that y is equal to f inverse of x if and only if f of y equals x. In other words, here's a sort of more verbal and less equation-y way of looking at this. F inverse of x is defined to be the input that you would need to give the forwards function in order to get x as an output. Right, so once again, what is f inverse of x? It's the input you need to give the forward function to get x as an output of the forward function. So, and I'm fussing over the definition here and sort of going over it a bit here because that is what you use in practice. So, out of all the things we talk about in this video, the most useful thing is actually this theoretical nonsense, the definition of the inverse. Okay, so here's one important consequence of the definition of f inverse. It follows that f inverse of f of x is equal to x, right? Because what is f inverse? It's the thing that you need to feed f in order to get the output f of x. Well, that's just exactly x. And for all x in the domain of f, and similarly, f of f inverse of x is also equal to x for all x in the domain of f inverse. So this is the point of f inverse. This is the reason why we define inverse functions. The point of an inverse function is that it undoes what f does and vice versa. So to look at a concrete example, so let f of x equals 2 to the x. As it happens, this is a one-to-one function, which is, again, not obvious but true. So it has an inverse. So let's look at the question, what is f inverse of 32? A very concrete question. All right, answer. Well, by definition, as we were saying before, f inverse of 32 is the input that you need to give the forward function f of x equals 2 to the x to get an output of 32. So I want you to think about what x you could plug in there to get an output of 32, and that'll be the answer. All right, pause your video now. Okay, in other words, f inverse of 32 is the solution to f of x equals 32, or in other words, f inverse of 32 is the solution to 2 to the is equal to 32. And again, see if you can pause the video now and think about what should go in there to make that equation work. Well, hopefully you realize that since f of 5 equals 2 to the 5 equals 32, and let me pause. You can pause the video one more time and try to figure out what that tells you about f inverse of 32. Well, what that tells you is precisely that f inverse of 32 is 5. All right. So let's turn our attentions to more global matters. How do f and f inverse compare overall? How do they sort of look in the big picture? Well, the short answer to that is that they look exactly the same, except everything about happens with f, you switch x and y and get something that happens with f inverse. So for example, the domain of f becomes the range of f inverse, and the range of f becomes the domain of f inverse. The graph of f inverse is actually the graph of f, but you flip it over or mirror it by the line y equals x. Okay, so returning to our example where the forward function is f of x equals 2 to the x, again, let me repeat that the domain of 2 to the x is all real x, and the range of 2 to the x is all y greater than 0. But on the other hand, if here we have the graph of the inverse function, so here's the graph of the forward function, f of x equals 2 to the x, and here's the graph of the inverse function, f inverse of x. So if you take my word for it that that is in fact the inverse function of f of x, we see that the domain of the inverse function is all positive x, just as the range of the forward function was all y greater than 0, and the range of the inverse function is all real numbers. That's a little harder to see, but that corresponds with the fact that the domain of the forward function is all real numbers. And furthermore, as we were saying before, the graph of the inverse function here is the graph of f of x flipped over this sort of line with slope 1 through the origin, the line y equals x. I mean, that is, here's the forward function, you flip it over, y equals x to get the graph of the inverse function. Okay, so finally we turn to finding the formula of an inverse function, and let me start with a hard truth, which is that if you're just watching this for the purpose of calculus, feel free to skip to the end, because calculus pretty much only really needs inverse functions when we don't have other formulas for them. So for example, the most prominent example is the exponential functions. The whole reason for talking about inverse functions with respect to exponential functions is that we don't have a better formula for the inverse function of 2 to the x than the natural log of 2, which is just another way of saying the inverse function of 2 to the x. However, just for completeness, to find the formula of f inverse, here's what you do. Given a formula for f, especially an algebraic formula, one, you set up the equation y equals f of x. You switch the variables x and y, step 2. 3, you solve for y, and 4, the end result is that you get something that looks like y equals some stuff in x, and the answer, f inverse of x, is equal to that stuff in x. All right, so turning to an example, so take f of x equals x cubed minus 7. Turns out that's not obvious, but it's true. That's 1 to 1. So to find a formula for f inverse of x, you set y equals x cubed minus 7, and switch the variables x and y to get that x is equal to y cubed minus 7, and then you solve for y. So then you add 7 to both sides and get x plus 7 equals y cubed. Take the cube root of both sides and get that y is equal to the cube root of x plus 7. And so that's your answer. F inverse of x is equal to the cube root of x plus 7. All right, well, what are you doing watching this? Go do something useful instead. Thanks very much, and bye!